In order for us to determine which value is more extreme relative to the data set from which it comes from, we need to calculate some z-scores. So here we're looking at the temperature of an adult, and we want to see if that's more extreme than the weight of a quarter. So before I start using formulas to calculate z-scores, I like to write down all of my information using the correct notation. So let's start with the adult temperature. Here we're looking at an adult whose body temperature is 99 degrees Fahrenheit. This data came from a sample of 106 adult temperatures. And so when we looked at 106 adult temperatures, we came up with a mean temperature of 98.20 degrees Fahrenheit with a standard deviation of 0.62 degrees Fahrenheit. So in order for us to compare, because these are two different values that come from two completely different samples, we have to compare the value and see how far away is it from the sample mean. So to do this, we're going to use the formula for calculating a z-score, which tells us to first calculate the difference between our sample data and see how far away that is from our sample mean. So that's what the numerator tells us. And then how does that compare relative to the sample standard deviation? So I write that down in the denominator. You can take out your calculator and do this simple calculation. So we can see here that this gives us a z-score of positive 1.29. Now let's do the same thing for the weight of the quarter. So the weight of the quarter of interest here is 5.779 grams. It comes from a sample of 40 quarters and their weights. So the average of those 40 quarters has an average weight of 5.6393 grams and a sample standard deviation of 0.06194 grams. So now, again, we want to know how does this quarter's weight compare to the mean of the sample? So again, we're going to calculate a z-score. Let's go ahead and calculate the difference between that value and the sample mean. So that's, again, what the numerator tells us. And then we divide it by the sample standard deviation. Again, take out your calculator and z-scores round to 2 decimal places. We see here that this has a z-score of 2.26. So now let's interpret our results. What do these z-scores tell us? So if we're comparing the z-scores, we can see here that a body temperature of 99 degrees Fahrenheit is 1.29 standard deviations above the mean, whereas the quarter is 2.26 standard deviations above the mean. So this tells us that a quarter that has a weight of 5.779 is a more extreme value than a body temperature of 99 degrees Fahrenheit because it is 2.26 standard deviations above the mean. So that means it's further away from the sample mean compared to that body temperature.